Hello everyone, welcome back again to Embed System course. So we are in chapter 2 and studying part 2 of this chapter, that is serial port programming in C. So in previous lecture, that is in lecture number 8 of this part 2, we studied mode 0 of serial port of 8051, that is a 8-bit shift register mode, which is not real universal asynchronous reception transmission. Okay, so uh, in this lecture number 9, so we are going to study mode 1, mode 1 of serial port of 8051, that is 8-bit UART with variable baud rate. That means in this mode we can uh, transmit or receive data serially by using asynchronous reception transmission mode, in which number of data bits that will get transmitted at a time, that will be 8 bits. Okay, that is 1 byte of data will get transmitted or will be received. So it is called as 8-bit UART mode. Okay, and this we can do with variable baud rate. That means we can set the baud rate as per our requirement to one of the standard baud rate if we have used crystal of 11.0592 megahertz. Okay, so for that we have to configure timer 1, okay, in mode 2, and we have to load proper value into th1 timer register. Okay, so in this lecture we will focus our study on studying this 8-bit UART mode, that is mode 1 of serial port of 8051. So this mode 1, serial port mode 1, is named as 8-bit UART with variable baud rate. So this mode can be enabled by setting the bits SM0 and SM1 from SCON SFR, that is serial control SFR. There are two bits SM0 and SM1. We have to make these bits 01. That means we are configuring serial port of 8051 in mode 1. Okay. Uh, then if we do this, then it will configure uh, serial port in 10-bit full duplexer receiver transmitter. Okay, so the meaning of this is, that is 10-bit means actually out of these 10 bits, 8 will be data bits, that is 1 byte, and remaining 2 bits are overhead bits. Okay, and these 2 bits are one start bit and one stop bit. Okay, so that are necessary to transmit that 1 byte of data. Then full duplex means at a time transmission and reception can happen on TXD and RXD pins of 8051, which are connected to other serial device. Okay, that is the meaning of full duplex receiver transmitter. Okay, then on pin RXD we can receive data serially, and on pin TXD we can transmit data serially, data bits serially. Okay, there is one more SFR is there, that is a PCON. PCON SFR is called as power mode control SFR, and from this PCON there is a one bit that is used in a serial communication. Okay, and that bit is actually S mod bit. Okay, so that bit is S mod bit. So when 8051 power up, okay, means when we turn on power to 8051, by default this S mod bit is 0. Okay, and that is actually D7 bit, D7 bit of this PCON. Okay, remaining bits are of no use in serial communication. These are used for other purposes. Okay, so these bits are not used in serial communication. Only this bit, S mod bit, is used in serial communication. By default it is 0. Okay, and by using this bit we can set, okay, we can set it to high, that is 1. Okay, by software, that is by using instructions in the program. and we can double the baud rate. Okay, so in mode 1 we can set a particular baud rate. For example, if we have set 2400 bps baud rate, okay, and um, we haven't changed this bit, that is it remains 0. We haven't configured this bit, and suppose the baud rate we are getting is 2400, and it depends on what value we have loaded in th1. Okay, th1 is the timer 1 timer register, that is higher order register. Okay, we have to load this with a particular value so that we can set this to 400 baud rate. So suppose in that case s mod is 0, and suppose now if I make it 1, okay, then this baud rate, okay, that is 2, previously it was 2400, it will get doubled and it will become 4800 bits per seconds. That is the meaning. Okay, means simply by setting this bit we can double the baud rate. That is the meaning. How to set this particular bit? So for that, we these three bits are not utilized, and these gf1, gf0, pd and ideal, these bits are used for other purposes. Okay, so these bits should not be disturbed. Okay, we have to just make this bit uh, 1. Okay, and probably this is not bit addressable sfr, so directly I cannot modify this smod. So for that the program is written, okay, to set this bit. So first, since this sfr is not bit addressable, I have to load the previous value of in pcon into first accumulator by using instruction move a comma pcon. So this instruction will move current content of pcon into accumulator. Okay, then set b acc.7. Now in accumulator what is there? Contents of pcon. Okay, so out of this I am setting bit number 7, that is this bit. Okay, so these bits are now available in accumulator, and accumulator is bit addressable, so I can set or reset a particular bit, and I am setting now bit number 7, which is s mod. Okay, in accumulator, so I have make it 1. So I have make it 1, and then I'm moving content of accumulator again to pcon, that is move pcon comma a, means it will move content of accumulator to again pcon. Okay, so by using these three instructions, what I'm doing without disturbing this data in these bits, okay, I'm just setting this smod bit to 1. Okay, so in this way I can set this smod bit and I can double the baud rate. Okay, so now this is the block diagram of uh, mode 1. Okay, and how that doubling of baud rate takes place. Okay, so as in mode 0, so serial port of 805 uses this crystal oscillator frequency as a basis, um, that is 11.0592 megahertz. Further it will be divided by 12. So here what frequency is available? That is f oscillator divided by 12, which is called as machine cycle frequency. Okay, because if here, if this is the frequency, okay, so this one period of this frequency is nothing but 12 clock pulses, and which is equivalent to one machine cycle, so it is called as machine cycle frequency. Okay, now this frequency further can be divided by 16 or 32. It can be divided by 16 or 32 depending on what is s mod bit. If s mod bit is 0, means by default it is 0, then this frequency, that is a if we assume crystal frequency 11.0592 megahertz, so it will be divided by 12 and that frequency will be 921.6 kilohertz. So if s mod bit is 0, that will be divided by 32, and the shift clock frequency that is supplied to timer 1, okay, is a 28800 hertz. Okay, so that is same like in mode 0, that is basis shift clock frequency is 28800 hertz. Okay, that is the rate at which reception and transmission happens Further, it depends on how we have configured timer 1. Okay, so if s mod bit is 0, I'm getting this baud rate. Okay, 28800 bits per second or hertz. And if s mod bit is 0, this frequency will be divided by 16, and I'm getting how much baud rate or shift clock frequency? 57600 hertz, which is double than this one. Okay, so in this way s mod bit works. Okay, so further this can be divided by 3, 6, 12, 24, etc., depending on what value is loaded in a th1 register of timer 1. Depending on that, I will get variable baud rate. Okay, so that is described in this table. Suppose th1 is loaded with -3, which is nothing but fd, because fd is 2's complement of -3, which is ultimately loaded, okay, into th1. Okay, so then if we load fd, then this 28800 or 57600 will get divided by 3, and I will get baud rate 9600 if s mod bit is 0, and I will get 19200 if s mod bit is 1. Okay, so if s mod bit is 1, this will be divided by 3 if I load fd or -3 into th1. So if we divide this by 3, I will get baud rate, that is 19200 bits per second. If s mod bit is 0, then this will get divided by 3, and I will get baud rate 9600 bits per second. Okay, in this way, depending on what value we are loading in a th1, okay, this shift clock frequency will further get divided and will generate desired baud rate like 9600, 4800, 2400, 1200, etc. If s mod bit is 0, and if s mod bit is equal to 1, it will generate 19200, 9600, 4800, 2400, etc. Okay, depending on what values you are loading into th1. Okay, in this way we can generate variable baud rate, and as well as we can double baud rate simply just by making s mod bit 1. Okay, so this is about baud rate generation. Now we'll study what happens in a serial transmission in a mode 1, which is a 8-bit UART mode. Mode 1 is 8-bit UART mode, means 8 bit of data will get transmitted, okay, serially. So so in mode 1, data byte to be transmitted serially, that must be loaded into SBUF. So these 8 bits should be loaded into internal SBUF. SBUF is 8-bit internal SFR. Okay, so these 8 bits should be loaded into SBUF, and once these 8 bits we load into SBUF, what will happen? These 8 bits will get framed in between one start bit, one start bit, okay, and one stop bit. Okay, and in between 8 bits are there. So total number of bits will become 10 bits. Okay, in which first bit is start bit, and then 8 bits of data with LSB first, and then one stop bit. Okay, so total 10 bits of data are available for serial transmission, and immediately transmission begins on txt pin of txt pin of 8051. Okay, means these 10 bits will be serially shifted with a set baud rate on this txt pin, and it will be received at the other end by other serial device. Okay, so this will happen when we load 8-bit data to be transmitted into SBUF. Okay, so these 8 bits will get framed in between one start bit, stop bit, and these 10 bits will get shifted over this TXD pin to the other serial device to which this TXD pin is connected. So this will be RxD pin at the other end. Okay, so on this RxD pin, data will be received, that is transmitted over this TXD pin of 8051. Okay, so this device will sample data, okay, that is transmitted over this TXD pin of 8051 at the middle of each bit. Okay, that I will explain. Okay, so data byte loaded into SBUF is framed into start and stop bit. Okay, so after that transmission begins. So first what will happen? Start bit will get put, okay, on this TXD pin. So this is start bit, which is a space. Okay, so this is called a space or logic 0. So it will remain for 1 bit of a time. It depends, and that this period depends on baud rate we have selected. Okay, then then out of this 8-bit LSB, okay, so this LSB will be outputted first. Okay, then that is D0 bit, then this is D1 bit, then D2, then D3, D4, D5, D7. Okay, or uh, sorry, it is opposite. Okay, so I will just, okay, so after start bit, so this bit will be D0, that is LSB bit, then D1, then D2, and so on, and last will be D7 bit. So these 8 bits of data, and then this is stop bit. Okay, this is stop bit. So stop bit will be marked, that is 1. Okay, so this is start bit and this is stop bit, and these are the total 8 bits of data with LSB transmitted first. Okay, so these 10 bits of data will be shifted on this TXD pin, and these 10 bits will be received at the other end on RxD pin of that device. Okay, at the middle of each bit, at the middle of each bit. Okay, here that will be sampled. Okay, receiver samples data at the center of each bit time. Okay, so after transmission of all these 10 bits, okay, after transmission of all these 10 bits, what will happen? TI, that is transmit interrupt flag bit set, gets set. Okay, once all 10 bits have been sent. Okay, and each bit interval, that is this period will be equal to 1 divided by baud rate. For example, if we have set baud rate 2400 bps, that is equal to 2400 hertz, then 1 divided by 2400 seconds. Okay, so that is the time required to transmit 1 bit of data. So transmitted data is sent in the format above, that is start bit 8 bits, that is LSB first, and then stop bit. So this will happen during transmission in mode 1, that is 8-bit UART mode. Okay, so second part, that is a reception in mode 1. Sorry, reception in mode 1. How reception happens in mode 1? So received data is obtained in same order. Okay, so first start bit, then 8 bits of data, that in which LSB will be received first, that is D0 bit, then D1, then D2, and so on up to D7. Okay, and in the end stop bit. Okay, now when all these 10 bits received by 8051, then RI flag bit will get set, indicating that all 10 bits have been received. Okay, so after that, what will happen? These 10 bits, out of these 10 bits, okay, out of these 10 bits, start bit and stop bit will get ignored. Okay, that is deframing of these 10 bits will be done. Okay, in deframing, what happened? Start bit and stop bits, okay, um, that will get rid of start bit and stop bits, and separated 8 data bits will be available in SBUF. ओके, सो दिस इज कॉल्ड एज डीफ्रेमिंग. म्हणजेच काय, 10 बीट्स मधले फक्त 8 बीट्स जे आहेत कामाचे डेटा बीट्स, Okay, so these are separated and will be loaded into SBUF. Okay, will be available in SBUF. Okay, and we have to immediately move this content of SBUF to some safe place, that is in RAM or in any other register. Okay, because if next byte is being received serially, okay, that may get overwritten into SBUF if we don't move the content of SBUF, that is just byte, just received byte, to a safe place. This byte will get overwritten by next byte being serially received. Okay, so reception triggered by falling edge of the start bit and continuous. Okay, so what will happen next? So reception triggered by falling edge of start bit. Okay, and continues if the stop bit is at 0 halfway through the start bit interval. Okay, so after receiving these 10 bits. Okay, so reception again trigger by falling edge of start bit. Okay, so again, suppose after receiving these 10 bits, okay, what will happen again? If suppose there is a start bit, okay, so start bit is 0. Okay, sorry, start bit is 0. Okay, so reception again triggered by falling edge of start bit and continues. Okay, if the stop bit is 0 halfway through the start bit, means after this start bit, okay, what we expect, we accept next bit as, okay, so um, here, if this start bit is remains 0 halfway, okay, then again we can assume that there is a continued reception. Okay, means next byte is being received. Okay, and we have to just wait for halfway um, of stop bit. If still it remains 0, okay, then we can assume that next byte is being received, and we have to continue receiving in next 10 bits. Okay, and this is, we have to just wait for halfway, because to um, that is um, to get rid of anti-noise measure. Okay, so that data could be 0 due to noise. Okay, so we have to make sure that the serial reception is continued. Okay, so for that we have to wait halfway through the start bit interval. In this way, reception continues. Okay, in this way reception happens in mode 1. Okay, now serial port mode 1 baud rate, how that baud rate is generated. So as I told you, that is in mode 1, to achieve baud rate, okay, variable baud rate. Okay, so these baud rates means variable. I can set it to some standard baud rates like 1200, 4800, 9600, and so on. So on. These are the standard baud rates. We can set one of these baud rate depending on our requirement, and this we can set only if f oscillator frequency is 11.0592 megahertz. This precaution you have to take. That is, if we want standard baud rate, oscillator should be of 11.0592 megahertz. Okay, so timer 1 is used to generate baud rate, particular baud rate out of the standard. Okay, by using uh, overflow flag, that is a tf1 flag bit. Okay, typically timer 1 is used in timer mode 2, that is 8-bit auto reload mode. Okay, so that means we should load th1 with some initial value, some xx, and baud rate depends on what value we load in th1. Okay, so this is the formula to calculate the baud rate that will get generate. So it is equal to 2 to the power of s mod, where s mod is a bit from pcon, power control sfr. Okay, so this bit is, that we discussed what is use of this bit. So this bit is used to generate baud rate, or double the baud rate. This bit could be 0 or 1. If this bit is 0, 2 to the power 0 will be having value 1. If this bit is 1, so 2 to the power of 1 will be 2. Okay, so that means if this bit is 0, there will be no effect on baud rate, but if this bit is 1, the baud rate will be doubled. Okay, because here factor, multiplying factor will be 2 in this case. Now see the formula: 2 to the power of s mod divided by 32 decimal multiply by f crystal, that is crystal frequency, divided by 12d multiply by 256 minus th1. 256 minus th1, that is same as we discussed in this. Okay, so this is f oscillator divided by 12. Okay, so see here, f oscillator divided by 12, and then further it will be divided by what, depending on what value we are loading into th1. Okay, what value we are loading into th1, with that factor it will get divided by. Okay, suppose if we are loading th1 with -3, that is equivalent to fdh, what will happen? So this part will be f oscillator divided by 12 multiply by 3, isn't it? Okay, because 256 means 255 minus fd plus 1, that is equal to 3. Okay, and this, suppose t mod bit is 0, 2 to the power 0 divided by 32 multiply by, so here this will be equivalent to, that is a 921 something. Okay, let us check. So this frequency is 921.6 divided by 32 divided by 3. 921.6 kilohertz divided by 32 multiply by 3. Okay, in this way it will generate a baud rate of 9600. 9600 bits per second or hertz. So in this way this baud rate will get generated. Okay, in this way we can set a particular baud rate, particular standard baud rate, just by loading proper value into th1. Okay, so in this way we can set a particular baud rate in mode 1. So for other modes the formula is given. Sorry. So mode 2 and mode 3, in case of mode 2, which is a 9-bit UART multiprocessor mode with fixed baud rate, in which baud rate is fixed. Okay, so baud rate will be, so 9-bit UART means number of data bits will be 9. Okay, and it is actually used in multiprocessor mode, means embedded system in which more than one processor or microcontrollers are involved. That is called as multiprocessor mode. So in that case 9-bit data bits will be transmitted or received. Okay, so 8-bit, out of these 9 bits, 8 bits we have to load in SBUF. Okay, and ninth bit in case of transmission, that will be TB. Okay, in case of transmission, okay, so that bit will be loaded into TB8 in SCON, and in case of reception, that bit will be available in RB8 bit of SCON. So these two bits are in SCON SFR. Okay, so during transmission we have to load ninth bit, we have to load 8 bits in SBUF and ninth bit in TB8. Okay, and while reception, the 8 bits will be received in SBUF and ninth bit will be received in RB8, and these two bits are in SCON SFR. So in this way reception transmission happens in 9-bit UART multiprocessor mode. Okay, and if we have selected mode 2, okay, that is a fixed baud rate. So what is difference between mode 2 and mode 3? Both the modes are 9-bit UART multiprocessor modes, but mode 2 is fixed baud rate mode and mode 3 is variable baud rate mode. Okay, so in case of mode 2, baud rate is fixed, that is equal to 2 to the power of s mod divided by 64 multiplied by f crystal. That means here we have two baud rates depending on s mod bit. S mod bit is 0 or 1. If s mod bit is 0, I will get baud rate that is equal to f crystal divide by 64, and if s mod bit is equal, then I will get baud rate f crystal divided by 32, that is double baud rate. Okay, and in case of 9 mode 3, that is 9 bit UART multiprocessor mode variable baud rate, that baud rate formula is same like in case of mode 1, that is the baud rate is equal to 2 to the power of s mod divided by 32d multiplied by f crystal divided by 12d multiplied by 256d minus th1. Okay, so this is the value to be loaded in th1. Okay, remaining formula is same as I explained. Okay, see this formula, same formula is there. Okay, in this way we can set a particular baud rate in mode 3. Okay, so in this way we can configure mode 2 and mode 3. Okay, for a particular baud rate. So this is just a diagrammatic representation of how the baud rate is generated. So in mode 0 means 8-bit shift register mode. So whatever F oscillator frequency, okay, that is the crystal connected to 8051, that is normally 11.0592 megahertz. Okay, if we want standard baud rate. So this is further divided by 12. Okay, that is F oscillator divided by 12. So this is the baud rate. Okay, in case of mode 0, that is fixed, with which data will be shifted on TXD pin or data will be received on RXD pin of 805. In mode 2, that is what is mode 2? That is 9-bit UART with sorry, fixed baud rate. Okay, so in this case baud rate is fixed, okay, out of 2. Okay, depending on whether s mod bit is 0 or 1. If s mod bit is 0, what is baud rate? That is f oscillator divided by 64. If s mod bit is 1, what is baud rate? F oscillator divided by 32. Okay, and in mode, so this is in case of mode 1 and 3. Okay, so this is figure C. Okay, so that is mode 1 and 3. In case of mode 1 3, what is mode 1? Mode 1 is 8-bit UART with fixed baud rate. And what is mode 3? 9-bit UART mode with fixed mode 1 is 8-bit UART. Mode 1 is 8-bit UART with variable baud rate. Okay, and what is mode 3? It is 9-bit UART with variable baud rate. Okay, so this block diagram applies to both, that is mode 1 and mode 3, that is variable baud rate. So here uh, this f oscillator f oscillator so this f oscillator, so this f oscillator further divided by 32. So here f oscillator either divided by 32 or f oscillator divided by 16, depending on whether s mod bit is 0 or 1. Okay, and this is not f oscillator, so let me correct it. So this is not F oscillator, it is timer 1 overflow. That is the rate with which TF1 flag bit resets. So here I am getting pulses depending on what value we are loading in TH1. Okay, TH1 मध्ये काय value load करते त्याप्रमाणे frequency of this depends. Okay, and that is acting as source frequency. Further it could be divided by 32, either 32 or 16, depending on S mod is 0 or 1. Okay, that means to double baud rate I can set this s mod bit. Okay, so that means in this mode 1 and mode 3, okay, baud rate that will get generated here, okay, it depends on what value we load into th1 and what is f oscillator frequency, which is normally fixed, that is standard one, 11.0592 megahertz. Okay, so we have discussed all these things just diagrammatically. This is represented here. Okay, so this is for mode 1 and mode 3. Okay, so this is about mode 1. Okay, of serial port of 8051. Okay, so that is 8-bit UART with variable baud rate, on which we are going to do programming. We are not going to study programming on mode 2 and mode 3, because these are 9-bit UART mode which are normally used in multiprocessor environments. Okay, so right now we are going to focus our programming on mode 1, that is 9-bit UART mode with variable baud rate. So in this lecture 9, we studied about mode 1 of serial port of 8051. So how that baud rate is generated, we studied how to set that mode rate, how to set this mode 1 by using SM0 and SM1 bits from SCON, we saw. Then we studied significance of S mod bit. S mod bit is used to double the baud rate. Okay. Then how to set the variable baud rate in mode 1, that we saw. By loading proper value in TH1, we can set baud rate. Okay, particular baud rate. Then what happens in a transmission in mode 1, we studied. Okay, what happens while reception in mode 1, we studied. Then uh, we studied about how that baud rate, okay, generates. Okay, the formula in mode 1 we studied. Okay, then we also studied about mode 2 and mode 3, how baud rate is generated in mode 2 and mode 3. Mode 2, baud rate is fixed, either of these two. And in mode 3, we can set a particular baud rate by loading particular value into th1. Okay, then we saw the block diagram representations in mode 0, mode 1, mode 3, and mode 2. Okay, so this is about mode 1, that is 8-bit UART mode. So uh, in the next lecture, we will study programs on this mode 1, that is 8-bit UART mode, and then we will finish with this part 2 of this chapter number 2, that is serial port programming in C. Okay, so this is all. If any queries, we can discuss these queries in live session. Okay, so I think I should stop here. Okay, thank you.